The counting circuit operates on two key concepts: frequency and square waves. The square waves of the circuit are created by the NAND gate oscillator section of the circuit. When the circuit is on, a 0 is showing on the 7-segment display. When I press the button, the NAND gate will receive a high and low input, which will cause it to oscillate between these two capacitors. Now, at the moment, it is counting down, but if I switch it to up, it'll start counting up because of the up and down pin on the 4510. To get a better understanding of how the circuit works, I've used the breadboard version of the PCB. Starting off, we have the button input. This uses a pull-up display where the pull-up is normally on and the pull-down is normally off if you were to have an LED in the configuration. This leads directly to the NAND gate oscillator. This creates the square waves that are used in the circuit to create counting. These are carried to the 4017 decade counter. The decade counter has a divide by 10 pin, which lengthens the square waves to create a more presentable counting later on. This carries the clock signal over to the 4510. The 4510 has output pins that have values 1, 2, 4, and 8. These 1, 2, 4, 8 values are carried over to the 4511. The 4511 is a 7-segment decoder and has the A, B, C, D, E, F, G values that are also present in the 7-segment display. A, B, C, D, E, F, G. Now, we are using resistors to make sure that, like any other LED, these don't receive too much voltage. We also have an up and down, which is used, which comes from the 4510. One of the core concepts in the counting circuit was frequency. The binary up and down counter provided a visual demonstration of frequency using the LEDs. The LEDs had the values 1, 2, 4, and 8. For example, the LED with the 1 value had a frequency of 0.5 Hertz. Hertz are the unit that describe how many cycles happen every second. So the first LED would turn on every second, and if we count a cycle as it turning on and off, that means it would complete 1 cycle every second, so it completed half a cycle every second.